Find the ratio in which P, located at 4m, divides the line segment joining the points A, located at 2, 3, and B, located at 6, -3. Hence, find M. So here we have our coordinate plane, and we have points that make a line segment, A and B. A is located at 2, 3, and B is located at 6, -3. And together they make a line segment. And we also have this point P. It divides this line segment, and it doesn't say it divides it in half. So we want to find the ratio in which P divides the line segment. Now we may not know exactly where point P is located at, but we do know it's located at 4, m. So its x-coordinate is 4. So we know that P is found on the line x equals 4 because its x-coordinate is 4. But we don't know why. However, we do know that P is also lying on the line segment AB. So P will be located where they intersect. Now it seems like we could kind of guess where P would be located. However, let's be sure and calculate that. Now we can find a point where two lines intersect, but we need to know the equation of the lines. We know that the dashed yellow line is x equals 4, but we don't know the equation of line segment AB. The equation of a line is equal to y equals mx plus b, where m is your slope, not to be confused with the m, the y-coordinate of P, but here in this equation, m stands for the slope, and b stands for the y-intercept, where it crosses the y-axis. So let's begin by finding the slope, and there's a formula for that. The equation for the slope of a line is the change in the y's divided by the change in the x's, so y2 minus y1 divided by x2 minus x1. A is located at 2, 3, and B is located at 6, -3. So we can let A be x1, y1, and B be x2, y2. So we have -3 minus 3 divided by 6 minus 2, and we get -6/4. However, this reduces to be -3/2. So right now, the equation of our line would be y equals -3/2 x plus b. So now we need to find b, and we can do so by using a point on our line. We could use A or we could use B. Let's go ahead and use A since it doesn't have any negative numbers. We will plug in 3 for y and 2 for x, and now we can solve for b. -3/2 times 2 is equal to -3 because essentially the 2's cancel. And to solve for b, we need to add 3 to both sides of our equation. And we find that b is equal to 6. So we can replace b with 6, and we already found the slope, which is -3/2. So the equation of line segment AB would be y equals -3/2 x plus 6. So now we want to find the y-coordinate of P. And we know that P lies on AB and on x equals 4. So what we can do is replace x in our equation of line segment AB with 4. And we can solve for y, and then that will be the y-coordinate of P, and we'll know where P is located at. 2 goes into 4 twice, and -3 times 2 is -6, and -6 plus 6 is equal to 0. So, for point P, if x is 4, y is 0. So, we have that P is located at 4, 0. So now that we know exactly where P is located, we can find this ratio in which P divided the line segment AB. So now we will be finding the ratio of the distance from A to P to B. And this will require the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So to find the distance between A and P, A can be x1, y1, and P can be x2, y2. So we have the square root of 4 minus 2 squared plus 0 minus 3 squared. So we need to square 2 and square -3. 2 squared is 4, and -3 squared is positive 9, and 4 plus 9 is 13. So the distance from A to P is equal to the square root of 13. So now we will find the distance between P and B. And we can let P be x1, y1, and B be x2, y2. So we have the square root of 6 minus 4 squared plus -3 minus 0 squared. So now we need to square 2 and square -3, and 4 plus 9 is 13. So the distance between P and B is the square root of 13. So to find their ratio, the square root of 13 to the square root of 13 would give us that the ratio of AP to PB would reduce to 1 to 1. So this means P is actually in the middle. It's the midpoint of line segment AB. So we found M to be equal to 0 and the ratio of AP to PB being 1 to 1.